Hi guys, Mrs. H here. Today we're going to be looking at compounds. So at the end of this, we'll be able to determine the difference between atom, molecule, and compounds. We'll be able to look at chemical structures of these atoms, molecules, and compounds, and actually look at chemical formulas. Notice there are some vocabulary words here for this unit. So what is an element? So an element is a substance that is an identical atom. So we have hydrogen element, helium element. Think of anything on the periodic table, and if it's on the periodic table, it's an element. These consist of a singular, the same element, the same structures. So helium, they're all going to have the same number of protons, electrons, and neutrons. Now, depending on the kind of element it'll determine whether or not it's a gas or a solid or a liquid at room temperature. So both helium and oxygen are gases in room temperatures, and they have very specific chemical properties. Now, there are some things to note, like hydrogen and oxygen. If you have those gas elements, they actually don't like to be by themselves. They'll actually be paired up. We call those diatomic elements. And there's a few of them. But then helium likes to be by itself and is all fine just hanging out by itself. So depending on the element, there's only a few of those that will pair up like that. But yeah, so element, singular, all by itself, one element, it's on the periodic table. So then what happens when I have two different elements found on the periodic table that are going to chemically bond or chemically join together? And what does that mean? That means there's something going on with their electrons. When we're talking about a bond, something's going on with their electrons. They're either giving or taking electrons, or they're sharing electrons. So there's some kind of electron interaction going on. And that electron interaction between two different elements make a compound. So an example of a compound, water. We're very familiar. Here's my water glass, right? Got some water in there. Thirsty? Well, what's that made of? That's made of two hydrogens and one oxygen, and they're going to bond chemically together. So if I take carbon, carbon is going to have very specific chemical properties by itself. It's going to be dark, black, solid. Oxygen by itself, the element. Breathe in, it's what fills my lungs so that I can use my brain and use my muscles. So I've got oxygen to get my energy. Very different than if I would have carbon and two oxygen together. Carbon and two oxygen together are carbon dioxide, and it has different chemical properties. I don't breathe in carbon dioxide, I push out carbon dioxide. So when two elements bound together form a compound, their chemical and physical properties also change. What else do we know about compounds? Compounds come in all kinds of different shapes and sizes. So water, itty bitty, teeny tiny. Where salt will have sodium and chloride, and they're actually going to be a whole bunch of sodiums and a whole bunch of chlorides, and they're going to actually form this lattice structure that we see here. Kind of looks like there's a game out there where you can flip the magnetic circles together, the magnetic spheres, and put them in all kinds of different shapes. That's what it kind of reminds me of. The table salt. So it's going to have a lattice. So depending on the type of compound will depend on the size of the compound. So let's look at here. What's the difference between, let me get my face here out of the way. So what's the difference between a molecule and a compound? Now, these two words technically are not interchangeable, although it seems like they are, but they're not. So compounds and molecules are different. So what is the difference between a compound and a molecule? So molecules, which are not compounds. So if I have two hydrogens, notice they're the same. So two hydrogen molecules together, notice I said molecules, those aren't a compound. Phosphorus, if I have those four phosphorus bonded together, Those are, again, a molecule, but not a compound. Now look at the difference on the other side. Here's molecules of water and nitrogen oxide and carbon dioxide. These are molecules, but they're also compounds because what happened? I have two different elements. So the difference between a compound and a molecule is compounds have to have two different. Now, we use the word molecule um, in a scenario where, yes, it is a compound, and yes, it is two different. An example of that would be sugar. So, sugar is a compound which is made of carbon, sugar, and oxygen, and we also call it a sugar molecule. And that's because the type of bonds. So, when in doubt, call it a molecule. Okay. However, it's kind of split in hairs. That's when you're getting into like your advanced chemistries. So let's think about this. I have methane gas. Notice methane gas has two different elements because notice the simple structure. So what must that be? Okay, notice your nitrogen. Notice it has multiple colors representing different atoms. So what must that be? Okay, try your oxygen, your neon, and sulfur. So how'd you do? So methane gas is a compound and a molecule, where so is vinegar, but your oxygen, neon, and sulfur. Your oxygen and sulfur, those are molecules, and your neon, because it's only one structure, it's an atom. Okay, so there are some rules for naming that are pretty consistent throughout. And so I want to go ahead and go over those. So, whenever we're naming a molecule and it has a metal and a non-metal, we always put the metal first. We look it up on the periodic table, whatever name it is, we write it down as is. The second word is always the non-metal. The non-metal, we change the ending to put in IDE. Now, there are some variations to that. If you have a specific type of bond, you might see prefixes or suffixes, or you might have a Roman numeral with this. So there can be some variations to that, but the basic part is you're going to have your metal first, your non-metal. Your non-metal is going to have IDE. Now, what happens if you have more than one? Then you're going to have some special names. These are called polyatomics, and there's a list of them. If you're in chemistry class, you'll memorize this list. And so we changed the ending to either ITE or ATE. Again, you're going to put your metal first, your non-metal second. So here's two examples. You have your copper sulfate or your copper carbonate. Again, notice I have more than two metals. And that's just the basics. This isn't the end all be all for naming, but this is just the basics for naming. So here's a couple of examples. I have helium chloride. I have sulfur trioxide. Notice the tri, that prefix I was alluding to. You have lead carbonate and then potassium oxide. So how do we count atoms? So counting atoms is really important. Because the number of atoms in a compound or in a molecule will change. I'll have something totally different, a new compound or a new molecule, if I change what it's made up of. So, for example, water is H2O, but H2O2 is hydrogen peroxide, and you don't want to drink hydrogen peroxide. So, the numbers of atoms matter. So, how do I represent that? So there's two words here. One is the coefficient. The coefficient is the number in front, and the number in front tells you how many molecules or how many compounds there are of the substance. And then the number behind it or next to this little small number, this in the subscript position, that tells you how many atoms of that substance there are. So let's look at this. So that means in this scenario, there would be 4 atoms of hydrogen, and then there are 2 atoms of oxygen. for a total of 6 atoms in 2 molecules of water. So how did I do that? Where did that come from? And there's a little formula or a little 5 steps to figure that out. And we're going to look at that in a second. What I do want to make note of is what happens when there's no number here. You don't need to put a 1 here, because if this letter is there, there's at least 1. So 1 is understood. So you don't need to put this 1 subscript. You just leave it off. Now, the other thing that you'll see sometimes is parentheses around a group of atoms. And what does that mean? That means there's actually, so notice there's a 2 subscript. So that 2 subscript belongs to both the hydrogen and the oxygen. So I have 2 OH with 1 calcium. So there's OH, OH, 1 calcium. Okay? And so we need to make sure we understand that this 2 is saying I have 2 of this substance. So again, let's see how I can count and determine how did I do all of that. So one, I need to write out the chemical formula. So it's 2H2O. Then I want to list all the atoms present. So what atoms do I have present? I have hydrogen and I have oxygen. The next step is I need to count the number of atoms in each molecule. Well, where do I get that? How do I figure that out? That's the subscript. So hydrogen over here, notice, has a subscript of 2, and oxygen doesn't have anything, so 1 is understood. So I put this subscript number with my hydrogen and oxygen. What's the next step? I need to multiply the number of atoms of each element by the coefficient. So hydrogen, remember we said, had a subscript of 2 times the coefficient of 2. So there's 4 hydrogen atoms. Well, how many oxygen atoms are there? Well, it has a subscript of 1. So 1 times the coefficient of 2 equals 2 oxygen atoms. So there's a total of 6 atoms in 2 molecules of water. So I'd like you to try a few of these out and see how you do. So here's your answers to the first 2. So let's walk through this. So sulfur, remember there is a subscript of 1. So 1 times 2 equals 2 sulfurs. So then oxygen, there is a subscript of 2 times the coefficient of 2. So 2 times 2 is 4. So I have 2 times 1 plus 2 equals a total of 6, right? So 2 sulfurs, 4 oxygens. So what about carbon dioxide? So I don't know why there's an S there. I'm sorry. Whoops. That should be a C. So carbon, there's a subscript of 1. Oxygen, there's a subscript of 2. There's no coefficient. So 1 plus 2 equals a total of 3. So how'd you do on 3, 4, and 5? Were you able to figure this out? If you are struggling on counting atoms, please make sure you're reaching out to me. If you're confused on the difference between an atom, a molecule, and a compound, please ask for clarification. I hope you guys had a great lesson. Bye, guys.